Organic Shorts.
Oh, yeah.
Howdy, folks. Hope you enjoyed that new intro. So we're going to talk about alkenes and alkynes in this organic short. Talked about alkanes last time. Those are where we have all the hydrogens and carbons being single bonded to one another. And we're going to end our name of that molecule with A and E. An alkene is slightly different in that we have at least one double bond present in the molecule. We're going to change the ending of that name to E and E. And then an alkyne is where we have a triple bond between two of the carbons. We're going to change that ending to Y and E. Our first example is going to be an exception to one of those rules. Generally, when we have a functional group, we want to identify where it is with a number. Now, because we're dealing with a molecule here, which is consisted of 3 carbons, we know that it has prop as its name. Now, for us, we can put the number 1 here, but regardless of whether this double bond is present between carbons 1 and 2 or carbons 2 and 3, if it was moved over instead to here, the numbering would change and we would result with still 1 propene. So in this particular example, this is one of those weird exceptions. We do not need the number 1 in the name of this. In a molecule where we typically do need the number of this, we can see here that we have a 4-carboned molecule, and so we know that we have a bute of some sort. We have a double bond present, so we're going to change the butane to now butene. We also now need to indicate where that double bond is located, and it's located on carbon number 1, so 1-butene. Coming down here, we have our next example here, and this is an example where naming priority starts to take place. And with naming priority, we will know that this double bond here has a higher priority than the alkyl group. The double bond has a higher priority than the alkyl group. And so when we number this, we want to give the double bond the lowest number possible. We might be able to get lower numbers in total if we start from the right, but it'll mean our double bond gets a higher number, and that is a no bueno. So right now we can see we have a 5-carboned molecule, so we know that we have a pent. We have a double bond, so we know that we have an ene group, and we'll indicate the location of that with a 2. And then we have this other group up here. This is a 1-carboned group, and so we know that this is a 4-methyl group. It's on carbon number 4, and it's a methyl group. So 4-methyl, 2-pentene. Again, the 2 is communicating where this double bond is, where the ENE is. So going down, we have another example here. Again, we want that double bond to have as low of a number as possible. So we'll go 1, 2, 3, 4, and 5, number like that. We have 5-carbon molecules, so we know that we're operating with a pent. We have a double bond, so we know it's going to change the ending to ENE, and we know that double bond is on carbon 2. Again, we're left with a methyl group out here, so we have 3-methyl, 2-pentene. Last example here, this is one dealing with a triple bond. Now, triple bonds are a little weird in that triple bonds are very rigid and very stable. They don't have the freedom to rotate, and they also don't bend most of the time. They're very, very strong proteins and molecules that exist there. And so with this molecule here, we can see that we have 1, 2, 3, 4, 5, 6 different carbons. I want you to focus in here on carbon 2 and 3 and see that, yeah, it's all one straight line. And I previously said that at the angles is where we're going to have carbons. Triple bonds are the exception to that rule. So we have a 6-carbon molecule. We know that we're dealing with a hex. We have a triple bond, so we know that we have a YNE, and that triple bond starts on carbon number 2. So for this, we have a 2-hexyne as the name of this molecule. That is your first organic short. Hope you enjoyed this video. Let me know if you have any comments at all.